the REC Foundation, we're dedicated. At the REC Foundation, we're dedicated to engaging.
All right. Let's start 4 or 5 minutes early. Oh, let me make sure the stream is there. Okay. I have to apologize about being sick today. Oh, wait. I will be resting up to make sure I can make it to class on Monday and Tuesday. Also, on Monday and Tuesday, I'll answer any questions about the final. If you've got them and you're not going to come, you got questions and you're not going to come, email them to me. I'll address them during the live stream that is going to occur from the classroom. So I plan to be in that classroom on Monday and in that classroom on Tuesday. But right now I'm going to cover out one thing that occurs. If you look at the book in this section, okay, so you have to look at what you're actually doing to find the second moment of the area. Okay, it's right. Okay. I can get up here. It's right here. So this is what you're supposed to do on these two problems. He has an interesting approach, which is not exactly what you've seen in the past. So what I want to do is, instead of using his approach, which he has this approach where he does this, he basically orients his bars either horizontally or vertically. And so he's got this whole description here. Makes it a little confusing. So what I want to do is just do this problem in an interesting way, in which I'm going to find IXX. Now, of course, I put them in here because it's X times X. I'm sorry, Y times Y, or Y squared on X, Y, Y. There we go, X squared dA. Now, when you see this, that's okay. The way he's doing it is okay. And you have some pages there to do that. But what I'm going to do is I'm going to do it a different way, the way you did in Cal 3 or whatever it was. So what you have in this one is you have this 1/8 x to the third. But you also have x is equal to 8 y, and I guess I'll say 1/3. Now, I use this code called Maxima, and the reason I do it is because you can sit right here and just type in your expression, your variable you're integrating, whether you want to do it definite or indefinite, and you drop it in there and it solves it. There are other websites. I know a lot of people have been used to using websites to do this. That's okay too. Maxima dates back way, way before websites even exist, and it's a pretty strong code. So let's look at this. Okay, so this tells you that, in fact, y squared dx dy, or how are you going to do this? Okay, so here's what we want to do. I think in hindsight, I guess I'll do the IXX first. I don't know that it really matters, and I may stumble a little bit here. So the key is, you've got, which one do you do? Dx, dy, or do you do dy and then dx? That's a good question. So, if you do dy, you're going to run your bar from here to here. So it's going to take me a few minutes to do this. So, yeah, let's do this one first. We're going to do this one first. So, do I put this in here? Do I do like this? Here's my two. I'm going to go through my two choices. First choice is to use this one. 1/8 x to the third. Now, if I'm doing that, I'll put a big or. 8. Wait a minute. You know what? 8 brought up to the, I think I know the answer here. It's 2. So, in fact, here. Okay. So, now what do? You kind of have to do the dy first and then the dx, or do you have to do the dx and the dy? Well, good question. We're going to try to do the dx and the dy. So we're going to look at this one later in a minute, and I think I've kind of goofed stuff up on it, but we'll zoom in on this. Okay, so if you're running dx and you have this right here, You are, hang on. I'm doing the y squared, right? Yeah, doing the y squared. Give me a second to think about it. I'm integrating out, so I goofed that one up. I'm integrating out x. But I'm going from x of 0 up to this goofy curve here. That's I almost said x squared, but that's an x to the third. Now, the next one, this is the dy. I'm just going from 0 to 8. Now, let me get rid of this one over here. I gotta get rid of it. What's wrong with this thing? Okay, so I'm gonna get rid of it. So if we're doing it this way, we're just basically running our bars. Or our boxes. The first internal integral, so I run my boxes from here all the way across to here. And so that's it. If I do that, the first thing ends up 0 to 8. Pretty boring. Wait a minute. I'm trying to think of how to adapt this thing to something you've seen before. Okay, let's look at the way he's doing it. Let's see how we can adapt it. Okay, the way he's going to want to do it for this IXX, you're going to want your bars to go like so. And he's going to tell you, and he's going to look at this A. In a very funny way. He's going to call this X and dy. So X dy is going to look a lot like 2y to the 1/3. That's because this is the X dy. And so then he's going to do like this. Y squared, and his dy is going to be, dA is going to be y to the 1/3 dy. And then he's going to run that from 0 to 8. This is what he does. Takes his bar, runs it left and right, and does that. Now, if we come back over here, I've kind of goofed up here because I got this X, and the X value here is actually that. It is not, this is a Y value. So in fact, let me see if I can explain that correctly. So in other words, I'm taking this box and I'm stacking it from left to right. I get all the way out here to the value of x. What is the x value there? It depends on the y. So if I'm up here at a value of like 2, what's the value of x there? We'll put in 2 right here. That tells you what that x is. But I have to write it generically. So I have to write 2y to the 1/3. Now, the x bar, wherever you're at, if you're up here, you're stacking a lot of the areas until they reach the edge. What is the value of x that they reach the edge at here? X would be 2y to the 1/3. So that's what this value has to be. This is the way you were taught in Cal 1. So in fact, what happens here, and I don't have room here, this thing seems as though it's a constant. So it kind of can be written like this. It's kind of stupid, but so inside this bound, inside this box, per se, it's its own integral. So it's like a 1 or a constant in there. The y is just going to sit in there or sit out here. It really doesn't matter. The y can be drawn out. So what do you get here? That internal integral ends up being simply 2y to the 1/3. It's kind of like saying the integral from 0 to 5 of dx is equal to value of x from 0 to 5. Or here, maybe I should say it this way. Some dz would be a value of z. Why is that z? Because dz equals to 1. That's the constant that's sitting right here. It's kind of like writing that. So in fact, from calculus, what you see is that's the case, which ends up being let's say that was 1 instead. It ends up being 5 minus 1. In this case, it's 0, so it's this minus 0. Upper limit minus the lower limit. And then you still got the dy, and you still integrate from 0 to 8. So if you look at this from this standpoint, okay, this is just for instance, you see that in fact, let me do this, the whole bracket around here. His approach of laying out the bar and your approach in Cal 3 or 2 or whatever that class you took was, is actually the same thing. It's just presented a little bit bizarre. And then you can go on through this, and then you can integrate, okay, 2y 7/3, y 7, wait a minute, that should be a 2. So that's 2, that's 6/7, and 1 more 7/3, dy, and from 0 to 8. Same thing that would occur over here. Just ends up equal to 2, and exactly y I should have put a limiter 8 0. Now, or I could have gone in here and done this. Let's do this inside the maxima. Let's see this. Now let's integrate. Let's do a definite integral with respect to y. We're going to cut 2 times y brought up to the 7 divided by 3. We're going to integrate from 0 to 8. Mismatch, you can see. What I mismatched my parentheses. Oh, did I put an extra parenthesis there? Why would I have done that? Oh, I think he gave me that. 3072 over 5. Was that, did I do that right? 0 to, wait a minute, y, 2 times y. Okay. 3072 over 5. Okay, 3072 over 5. Was that correct? 3072. Okay, well. Okay, let's say you want to turn that into 3072 over 5. 614.4. 614.4. I think that's the right answer, I think. Okay, so let's look at the other one. What should I do? Should I move these off to the right or copy them? I will copy them. Put one right there. Put one right here. Oh no. Right there. And there they are. What I'll do is do like so. And now, no, that's the wrong pen. Now, I'm basically doing the x squared dA. The integral, okay, I, y. So, let's try to relate it to your, okay, let's relate it to what he would do. Okay. I'm not a great drawer. This is what he's going to want to do. You want to say dx, okay, the area is equal to okay, so this is going to be 8 minus the y. But the y sits right there. So area is equal to 8 minus 1/8 of x to the third dx. Okay. So then what he's going to want to do is he's going to say, this is him in the way he's doing things, where he basically sets up this little area here. And then he basically says, equal to the integral x squared and the d area. So I'm sorry, that should be d area. Is this bar? It's 8 minus 1/8 of x to the third dx. Now, how would we have done this had we done this with the double integrals, the way you would ordinarily do? Well, you got your x squared. If you want to make them independent, you can do your dy and then your dx. So this makes this thing This makes this thing interesting because if you do it this way, you can pull this out. But if you're running up and down your Y, then, and what I'm going to do is experiment in a minute. I'm going to run it the other direction. So if you're taking your bar and you're running them up and down your Y, where are you running your limits to? You're starting your lower limit here. You're doing your lower limit. Let me get rid of the squiggly now. Your lower limit is at Y to 8. But your deal is, what is Y? Well, Y is equal to, if I, okay, 1/8 of x squared. If I want to, that's, let me rotate my pen around. That's where that is. And then this time you're running from 0 to 4. And what I'm going to do is monkey with this a little bit. And we'll see if I can really monkey this thing up. But first, let me get through here. Since the x can be considered kind of independent of this, it can be drawn out. And we have x squared, the integral from 8, 1/8 x squared dy and dx. So inside your box becomes 8 minus 1/8 x squared is inside that box. Now if you look real close, that is the same thing as this, which is the same thing as that dA up there. Well, okay, maybe it's not the same thing. If you consider the dx with it, this would be the same thing as his dA that he would have gotten with his method. In fact, what I'm trying to do is relate this to stuff you've seen before. Now you got that. Now if I want to be, and don't want to necessarily work this out, I go to maxima. And this time I go into calculus. I would integrate x squared times 8 minus 1 divided by 8, or I could say 1 minus x squared divided by 8. And see, there's what I was doing. I had the extra parentheses there. I want to do a definite integral. I want to go from there to 4. And I want to hit OK. And he says it's 2176 over 15. Now I know I can do it inside of that, but it's just easier for me. 136. That's really weird. Why? Oh, wait a minute. Zero to 4. Did I do that right? Let's see. X squared. X to the third. Sorry about that. Oops. You have to, with this, x to the third button. You have to hold shift and then enter. 256 over 3. 256 over 3. So I am so sorry. That's x to the third there. So this should be x to the third. X to the third. And that should be third. And then go back and make sure x to the third over 8. Yeah. 256 over 3. Which in fact, over 3, 85 and a third. Okay, so that's the right answer. Now I'm going to really try to mess up the works here. And see if I mess this thing up. Now, what I'm about to do is experimental. And I do this a lot for myself just to see if I can understand the concepts here. So here I drop this thing. And I just want to make life very interesting by integrating dx and then dy. Okay, can it be done? Okay, can this be done? Okay. This time I'm taking my boxes and I'm going through this till I line up. So I'm going from 0 to this location here, to some x location, which is 2 y to the 1/3. So I'm doing something really weird and very uncomfortable. If I do that, where's my y integral going? It's going from 0 to 8. So I'm stacking my boxes backwards. In other words, in his case, he wants you to stack your boxes vertically here and on this other horizontally here. So I'm now stacking the boxes horizontally and seeing, can I get the same answer? And I'm experimenting. This is purely experiment here. So don't be surprised if it doesn't work out. But I think I'm okay, but this is not enjoyable in a way. So let's take the first integral and let's just, I don't know if it will allow me to do this. I mean, if it doesn't, that's okay. Okay, so I'm going to put in the x squared. I'm going to do a definite integral. And I'm going to do it from 0 to, see if this will work, 2 times y brought up to the 1/3. Do not know. He closes his brackets. I don't know if it's going to work. It does. Okay, so 8 y to the 3rd. 8 y to the 3rd. Okay. 0, 8, and dy. So what did I do? Okay, let me move this down. Let me do it in a sense here. X to the 3rd over 3, evaluated from 0 to y 1/3. And there's an integral from 0 to 8 dy. But if I look inside here, of course, if I plug 0 in here, I get nothing. So that thing should be 2 y to the 1/3, 3rd power over 3. So 2 to the 3rd power is 8. Y to the 3/3 is just y, and then you get a 3rd. That is what's stuck right here. Is the remainder of this correct? Okay. So if I integrate that, that's y over 3. Well, here, let's make sure. I'm going to do a indefinite integral in which I'm going to do 8 times y divided by 3, integrating with respect to y. And I hit that, and my output is 4y squared over 3. 4. That's evaluated from 0 to 8. So I get 4, 8 squared over 3. Let's see. I could have done the definite now and made it, but I would still have to come back. 8 squared over 3. 85.33. Or 85, let's just say 85.3. So my experiment yielded the correct result because that's the value here. That's the value. I never did this integral because I noticed it was the same as that. And it's the same here. So unlike what he's doing in the book, you're open to do either y squared dx dy or y squared dy dx. You should get the same result. Likewise, x squared dx dy should come up with the same thing as x squared dy dx. You just have to make sure your limits are going the correct way. And so I hope this kind of explains that actually what you've done in Cal whatever, 2 or 3, actually covers all of this. If you can get to that frame of reference, the first thing you saw, let me kind of review it. The first thing you saw is what he's doing here is he's building these bars that are either horizontally or vertically. Here, we got a horizontal one. And so your dA becomes, in this case, he's listing it as 2y 1/3. I hope I like that. dy. That's what he's doing. He's defining that. And then he just puts this in. What calculus told you to do, it told you to do a double integral. Calculus told you to do this. Are they the same thing? Actually, they are. But the calculus, in my view, is a little less confusing than looking at vertical and horizontal bars. And there's a reason behind that, and that is if you do a vertical bar when you should do a horizontal bar in his way, you get an extra complexity that I just don't find is very useful. So to me, when I'm faced with doing something like this, the integral, I go to this immediately. Or I go to the other form of it, which is either this one, or I go to that one, or that one, or that one. And so all you have to look at is where your bars go from and to. Look at your limit, you do your integration, and that's pretty much it. There's nothing more to this. So I hope that kind of made a little bit of sense. And if it didn't, I guess rewind the lecture and look at it a little bit. I think there is a problem on the online portion of the final. I know that I'd like to have as many people show up either Monday or Tuesday, so we can kind of discuss this a little bit. And I'm going to probably produce a review of the way I'm going to write the in-class portion of the final. I hope you got the email. If not, I'll send the email out again. I'll send the grades out later, like twice this weekend. The goal there is going to be to make sure, put that extra 40% in there so your email will look a little bit different. And the first time I send it out, which will probably be tomorrow, will include the new 40% that's added in that column that I'll have to add in Blackboard. With that, outside of the complexity that was incredibly upsetting for me, and I know it probably was for you as well, I think we're good. If anybody has a comment, here, I'll turn around and look at the, I'll do this. I put a little thing in the, what is that called? The chat that says questions. So if anybody has a question, shoot at me. Somebody put a thumbs up on it. I can put a thumbs up too. What if I put 2? Oh, okay. So there you go. There's a share and a save. I don't know what the save does. Oh, it saved that video. Share basically opens that to send it out. Okay. Looks like the screen kind of, hang on, let me turn the volume up for a second. Okay, it's working. All right. So I think we've covered most everything. Monday and Tuesday in the stream, I'll talk about the in-class portion of the final. And I'll be in the class. I will rest enough over the weekend so that I'm not sick again. And we'll just go on from there. Let me see. And so I think we'll call it good for right now.